Welcome once again to the industrial pharmacy class. And in this class, I am going to discuss about liquid orals, its manufacturing process, and the various filling methods used for filling um, syrups into syrup bottles. Now, this is one of the typical syrup formula which I am showing over here. This is a formula which consists of the drug with along with excipients like sodium benzoate, menthol, alcohol, flavor, and a coloring agent, glycerin, sorbitol, and sugar, granulated sugar, and with purified water. And this is the formula for 1 ml, and this is the batch for 5,000 liters. And now we'll see the formula. This formulation will be prepared by using the following process. So this process is very, very significant, especially for any liquid oral preparations. The prime important thing what is to be considered in liquid oral preparations is the jacketed vessel. The main component or equipment which is needed is the main compounding tank. This is called the main compounding tank, and it requires small containers or small beakers or small stainless steel vessels wherein each and every excipient which is used in the syrup formula should be dissolved independently with a suitable solvent, either in alcohol or in water or in sorbitol or whatever it may be. So each one of the excipient must be dissolved in a suitable solvent, and it should be added to the rotating or stirring, continuous stirring compounding tank. This is the fundamental thing that it should be considered. Once this is followed, the entire process becomes very, very easy. And among all the dosage forms, liquid oral preparations are the simplest. Okay, now let us go into the manufacturing process of this syrup formula. And I have given this pictorial representation. Let us concentrate over here. Now, this is the main compounding tank, which is a jacketed vessel, wherein you can able to circulate hot water in the jacketed vessel, or you can able to say you can also circulate cool water if you wanted to reduce the temperature. And can you see the blue strips on either side of the kettle? They are called baffles. The main purpose of baffles is to allow mixing of the ingredients. And at the center, you have a stirrer which is continuously rotated by the motor. And it has a lid at the top and a hemispherical bottom. And to one of the walls of the kettle, you have the scale that is being etched, and you can able to find out what is the volume of preparation that is taking place in the compounding tank. And to one side you have the feed inlet, wherein you can able to connect through a pipe for the excipients to be added in a solution form. Okay, the first thing is you dissolve the drug in a suitable water. That means you take water and heat it to a temperature of 50 degrees centigrade. To that, you add a drug with continuous stirring. Once the drug is completely dissolved, then add sodium benzoate. And once it is dissolved completely, then add sugar in small quantities until the syrup is being prepared over here. And thereby the entire sugar is being dissolved, and this becomes a homogeneous preparation, and it becomes a viscous preparation. And once the sugar has been completely melted in water and a homogeneous preparation is resulted, then immediately start reducing the temperature to room temperature, maybe around 30 degrees centigrade. Bring it to 30 degrees centigrade. At that time, you transfer all the contents into the mixing tank. Into the mixing tank, The total capacity is 5,000 liters. That is the batch size. You add at least 2,000 liters of water into the kettle, and you switch on the motor and make this stirrer to continuously rotate during the entire manufacturing process. Once the contents in the vessel one are transferred into the water which is being present in the compounding tank, thereby the contents will uniformly mixed with that of the water, and this blend will be rotating. To this mixture, what you are doing, what is the next step is you dissolve sorbitol in water, add glycerin to water, dissolve and add the contents to the main tank. To another vessel, you dissolve menthol in alcohol and add to the main container or main compounding tank. In another vessel, take water, dissolve dye FDC yellow number 6, and this yellow color is added to the main tank. Then finally make up the volume with water by adding to the main tank until 5,000 liters. And the entire preparation or the mixture is mixed for a certain amount of period, and afterwards the entire syrup is being filtered by using plate and frame filter press. Then the filtrate is collected into the holding tank, and from the holding tank it is being passed on to the filling station, where the filling station can be a volumetric or vacuum filling method or gravity filling method. We'll see whatever it may be. Generally, vacuum filling method is being used. And afterwards, the syrup bottles are being filled with the liquid oral preparation. This is how the product is being manufactured, and this is being marketed ultimately. So ultimately, this entire formulation, the syrup formula, is being prepared and marketed, and the process is being explained clearly regarding the oral liquid orals. Now let us see the filling of syrups. So the filling can be done in three ways. One is gravimetric filling, where large containers and highly viscous products are being filled. So if the products are highly viscous, then gravimetric filling is being recommended. If not, volumetric filling is being recommended for syrups and liquid orals which are having free flowing nature. And another method is constant level filling, where this is also used for liquid orals. So among all these, volumetric filling is the most versatile one, especially for automatic filling machines. Coming to volumetric filling, this is accomplished by positive displacement piston action. So the main component which is mainly responsible for giving the desired volume to be filled into the container depends upon the piston pump. This is the pump. So this positive displacement piston pump is mainly responsible. We'll see how that works and all those things. Okay. And each filling station is equipped with a measuring piston and cylinder. So every station has a positive displacement pump, and the displacement of the piston will give you a fixed volume. That means suppose if 100 ml is to be filled into the bottle, so how much distance is sufficient to give exactly 100 ml to be filled into the bottle is the arrangement that should be done in the positive displacement piston pump. That distance should be fixed or should be set in the piston pump. The fill accuracy is controlled by the close tolerances to which the pistons and cylinders are manufactured. So here, so the fill accuracy means the volume of liquid which this let us say 100 ml which is to be filled into the bottle depends upon the pistons and cylinders which are being used in the positive displacement pump. And the fill amount is measured by the stroke of the piston. As I told you, once the piston moves from one end to the other end, it displaces a certain distance that is exactly equal to the volume that is to be filled into the container. And if you see in this picture, this is the syrup which is to be filled into this final container. And can you see this is the piston pump? Can you see this rectangular box like this is called the piston pump, and it is being connected from the hopper to the filling line by means of this piston. So the piston will be moving from this end to this end. Once it is moving, what happens is, suppose suppose the piston is has moved from here to here, from here to here. So once it has moved from here to here, means it draws a certain amount of liquid into the piston and it gets filled on its displacement. It fills into the container. So this is how the piston pump works. So what you have to do is initially you have to set the piston pump in such a way that you have to see for this distance how much volume is getting filled into it. So for 100 ml, how much should be displaced, how much distance the piston must move should be initially adjusted, and that should be fixed. That is how the fixing of the piston pump is done to give the exact volume to be filled into the container. Even a slightest mistake or a slightest increase in the micron length of the piston will lead to huge loss of the liquid preparation. Why? Because even a small zero point 0.1 ml extra in the bottle will lead to a huge amount of liters when it comes to a batch size of 5,000 liters. So that is why the piston pump plays a very important role in terms of filling the container. Next, coming to the constant level filling. This is another method. This method uses the container as the means of controlling the fill of the each unit. That means what? By taking the container into picture, the constant level filling is done. So the fill amount is varied by adjusting the height to which the container is filled. Any dimensional variations in the container results in comparable variations in the net fill per unit. The oldest form of constant level filling is the use of a siphon. So here the constant level filling is being generally done by a siphon. What is meant by siphon? Siphon is nothing but a U tube which is in an inverted form. And this method is slow and is rarely used when high production rates are required. Let us see how this siphon will look like in the next slide. Okay, now coming to this picture, can you see this U tube, bent U tube? This is called the siphon. So the contents will be moving from one container to the next container. Similarly, this is another picture depicting. So from here to this container, the liquid is being filled by using this glass pipe or this U tube or U pipe. Okay, that is called the siphon. This is called the siphon. This is how the constant level filling method is carried out. But vacuum filling method is the most versatile one, where it is filled by vacuum and a seal will be made between the filling head and the container. So I'll tell you how this vacuum filling method will work in the subsequent slide, where I'll show you the picture and I'll explain. Okay. So here the seal will be made between the filling head and the container. Where is the seal made? Here. Can you see here? Can you see the filling head over here? This is A is called the filling head, and filling head and the container. Container means what? See, this is the pipe. Can you see the pipe B? So you can able to increase the you can able to slide this pipe B. So that is called the filling container pipe. Okay. So this is how the displacement or setting up of the filling of volume by vacuum is being done. So it is done by vacuum, and a seal must be made between the filling head and the container. A vacuum is then developed within the container, which causes the liquid to flow from the bulk liquid tank to the container. So the liquid level rises until it reaches the vacuum tube, which is positioned at the desired constant level. and excess liquid is drawn through the vacuum tube and can be recycled to the bulk liquid tank. Now, let us see this figure once again so that you'll get a very clear understanding. For example, if you see here, this is the compounding tank which is consisting of the liquid oral preparation, and here this is the inlet for the filtered air to enter, and this is the pipe wherein it is being connected to the container, and this container is empty in the initial stage, and this is fitted with a filling head, and to this filling head you have a pipe which is connected to the vacuum. So what happens is when you apply vacuum to this pipe, so what happens, the air here is removed and this space becomes empty. And since the liquid storage tank is at a high pressure, the liquid passes through the pipe as this place is void or empty or vacuum is created. So thereby the filling will take place and it gets filled. And once it is coming to the point where the vacuum is stopped over here. So at this point, once the liquid touches this capillary, what happens is vacuum stops. So once it stops, the filling also stops, and the excess will be removed through this pipe and it will be sealed. So this is how the filling is done by vacuum filling method. Have you understood? So here also I've written the same thing for you to understand. The vacuum drawn through tube C, reduced pressure in the container, pressure differential causes liquid in storage tank to flow through pipe B, tube pipe B into container. When the liquid level reaches point A, excess is carried out through tube C and may be recycled to liquid storage tank. So this is the how the vacuum filling method is carried out. So this is the most versatile one, and there is also two more models in filling vacuum filling methods. One is gravity vacuum filling, wherein the bottom of the liquid storage tank is at a level above the filling head. That means what? Here, this one will be at a higher level and this one will be at a lower level when it comes to gravity vacuum filling. When the other case, pressure vacuum filling, a positive pressure is applied to the liquid in the storage tank. So what happens here? Here you have an inlet for the filtered air. So through here, if you apply positive pressure, it pushes the liquid with greater force. So that is another method called positive or pressure vacuum filling method. So these are the various filling methods which are widely used for filling up of liquid orals, and we'll see some more concepts in industrial pharmacy in the subsequent classes. Thank you and have a great day and see you soon in another class.